Alright, here's my sixth example for inverse Laplace transforms. Uh, well, we can take a look at the table of Laplace transforms, but there's not going to be anything that looks like that. Okay, so what we're going to have to do here is we're going to have to use partial fraction decomposition. Okay, so the first thing I'm going to need to do is I'm going to need to factor this part of the denominator here. So I have s squared plus 4s plus 3 is equal to s plus 3 times s plus 1. Alright, so let's just work with this inside here and let's break this up, okay, using partial fraction decomposition. So I have 2s plus 4 over s minus 2 times s plus 3 times s plus 1. And that is equal to a over s minus 2 plus b over s plus 3 plus c over s plus 1. Alright, so hopefully you remember how to do this. Okay, you should still remember how to do this. Alright, so now I'm going to multiply everything by s minus 2 times s plus 3 times s plus 1 by the common denominator. And that's going to leave me with 2s plus 4 equals a times s plus 3 times s plus 1 plus b times s minus 2 times s plus 1 plus c times s minus 2 times s plus 3. Alright, so now let's see, let's start out and let's let s equal negative 3. That'll get rid of this term and this term, and we'll be able to solve for b. Alright, so I'm going to take the negative 3 and I'm going to plug it in for s into this equation here. Okay, I'm going to plug the s in. And when I do, that's going to give me negative 2 equals 10b. And so b is equal to negative 1/5. Alright. And I mean, I didn't show that step there, but you should be able to plug the numbers in and get this. Alright, and then I'm going to say s equals negative 1. That's going to get rid of this term and this term, and I'll be able to solve for c. So when I plug negative 1 into here, that is going to give me 2 equals negative 6c. And so c is equal to negative 1/3. And then I'm going to let s equal 2. That'll get rid of this term, and I'll be able to solve for a. And so when I plug it in, I get 8 equals 15a. And so a is 8 over 15. Alright, so now let's go ahead and get back to our problem. We have the inverse Laplace transform of 2s plus 4 over s minus 2 times s plus 3 times s plus 4. And that is equal to, okay, so now it's equal to this. And I'm going to plug in 8 over 15 for a, negative 1/5 in for b, and negative 1/3 in for c. Alright, and so this is going to give me the inverse Laplace transform of 8 over 15 over s minus 2. See, I plugged the a in, and then I'm going to plug in negative 1/5 for b, so minus 1/5 over s plus 3, and then plug the negative 1/3 in for c. Alright, so now what we need to do is split these up into separate Laplace transforms. And you can see I have s minus 2, s plus 3, and s plus 1 in the denominator. And you can see that that's going to be this number 2 here. See the s minus a in the denominator? So what do I need in the numerator? Well, I need the 1. I need a 1 there. So all that means is when I split these up, I'm going to factor out a 8 over 15, a 1/5, and a 1/3. So this is going to be 8 over 15 times the inverse Laplace transform of 1 over s minus 2 minus 1/5 times the inverse Laplace transform of 1 over s plus 3. But watch this. See, I have a s plus 3, and my formula is s minus a. So I have to rewrite it to look like this. So I'm going to rewrite s plus 3 as s minus negative 3. Okay, so that gives me the s minus a. A is negative 3 in this case. Minus, and then I'm going to factor out the 1/3, and that's times the inverse Laplace transform of 1 over. Now the same thing that we did here, I need s minus a, so I'm going to write that as s minus negative 1. Alright, so we take the inverse Laplace transform of this. Well, that's 1 over s minus a. In this case, a is, in this problem, a is 2, a is negative 3, a is negative 1. So that's e to the at. Alright, so this is going to be 8 over 15 times e to the 2t minus 1/5 e to the negative 3t minus 1/3 e to the negative 1t, which is just negative t. And this is our answer. Alright, so I hope this video's helped. Hope you'll check out my other videos, and you can subscribe. Alright, thanks.